So this last section of the module, which is integrals, exponential functions, and logarithms, we actually have done most of this. We wrote the definition of the natural logarithm as an integral. We've done that. Recognize the derivative of the natural logarithm. Integrate functions involving the natural logarithm. Recognize the derivative and integral of the exponential function. Prove properties of logarithms and exponential functions using integrals, and express logarithmic and exponential functions in terms of natural logs and exponentials. Okay, so we've done most of that. The only thing I wanted to focus on, because we did all that in the previous chapter, and I forget what section that was. Section 1.6, we did a lot of that. So what I want to do is just go through some review in this section. So we remember that the integral of du over u is just the log of the absolute value of u plus a constant. And the integral of e to the u is always e to the u plus a constant. So we're going to work through some of these problems. And here we go. Okay, so what's u for this problem, please? What is u?
6x squared plus 9.
Thank you. Okay, du.
12x
12x what?
dx.
Good. 12x dx. Okay, so I see that I have here 4 dx. So I'm going to solve for that part, just dx. I'm going to solve for x dx. And so now I get x dx is 1 over 12 du. Okay, so life is beautiful. This is the integral. I have 4. X dx is 1 over 12 du.
I'm sorry, I got a quick question.
Yes.
Could that also be 1/3 du?
It cannot be one, yes, but you would have to have the 4x there. So you could write 4x, I agree with you. You could just divide this by 3 and get 4x dx is 1/3 du. So you could just replace the whole 4x dx by 1/3 du, or you can just replace the x dx divided by 12, and notice that over here, I'm still going to get 1/3.
Okay.
So either way is fine. So this is 1/3 the integral of du over u. And what does that give me? What is du over u? The integral?
ln u.
Natural
Plus C.
log of the absolute value of u plus a constant. So my answer is the natural log. Oh, no, it is not. 1/3. It is 1/3 the natural log of the absolute value of u. Oh, I'm supposed to be plugging in u. I'm getting sleepy. 6x squared plus 9 plus the constant. Okay. Any question? Okay, number 2. Uh-oh. Okay, write down what u is, please. And then take du. Write down what u is, and then take du. Okay. Somebody want to start me off?
U is 3 minus x cubed. And then du is negative 3x squared dx.
And what was du?
Is it negative 3x squared dx?
Okay, so how do you keep going from there?
You have to find x dx.
Okay,
So divide by negative 3x
okay.
to
I'm
get.
just going to divide by negative 3 du.
Okay.
So I'm going to have negative 1 over 3 du. You understand?
Okay. Yeah.
So I kept this piece. And I got x squared dx is equal to negative 1 over 3 du. Okay, let's put it all back together. Integral, I have a 4 there. X squared dx is negative 1 over 3 du. That thing in the denominator is just u. So I have negative 4/3 the integral of du over u again. That's negative 4/3. The log of the absolute value of u, which is 3 minus x cubed, plus a constant. Any questions? Okay. All right, this one's so easy, it's scary. Okay, so what is u? Okay, thinking. What is u? Is anybody doing this problem?
Is it tan of x plus 6 or no?
That's right. Okay, so what's du? Derivative of tangent is?
Hold up. Sorry. I'm having a brain fart. I can't remember right now.
I understand. All right, derivative of tangent.
Is it secant squared?
Secant squared x.
It is secant squared. Okay, so this becomes secant squared x dx, and that looks perfect to me. So this is the integral secant squared x dx is du over u. So that's the log of the absolute value of u, but u is the tangent of 6. No, it's not. It's the tangent of x. Plus 6 plus the constant. Okay, any questions about that? I know it seems strange to have the tangent of x plus 6 plus the constant, but that's what it is. Okay, I think we do have enough time. Let's do number 4. Okay, let's do this next one.
Is u 4x plus cosine of x plus 9?
Yes. Du.
Oh, is it for the negative sign of x? Oh, dx, yeah.
X. Good, 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 good. This one's another perfect substitution. Okay. All right. Switch it up a bit. Number 6. Oh, I gotta finish this. Whew, I tell you. Integral of du over u, log of the absolute value of u, which is 4x plus cosine of x plus 9 plus the constant. Okay. Needed to finish that. Number 6. Little different kind of problem. So what's going to be u?
X to the third.
Yes. All right, so du is 3x squared, good, dx. Okay, so now how can I manage this? What am I going to do? I know that that term is e to the u. If I make 4x dx, if I make x dx just the general form, then that means x squared dx would be 1/3 du. Okay, any questions? So now I'm just trying to solve for the x squared part dx. So now I know that this integral has a 4 in it. And then the x squared dx is 1/3 du. So this is 4/3 the integral of e to the u plus a constant. Now, how does that look? How does that look? That should look easy. And the reason why is because when we did integral of, when we just wrote it as e to the u, the only other thing in the problem was the constant. And that's 4/3. So this becomes 4/3 e to the e to the x cubed plus a constant. Okay, let's do number 7. Nope, same function. Trying to get to number 7. All right. All right, what do I do? What do I do? What do I do? What's u?
Cotangent x.
Okay, so whenever I have an exponent to like e to something, I really want to try to make that u to make my problem simpler. Okay, so how do I take the derivative of cotangent? What is it?
Cosecant squared x.
Cosecant squared x. All righty, dx. Okay, so it looks to me like I've got everything. Here's cosecant squared x dx, and the only thing that leaves is e to the u. So that's e to the u, the integral of it. Ooh, not e to the 4th, e to the u. And then cosecant squared x dx is just du. So this is just e to the u plus a constant, but that's going to equal e to the u, and I forgot. Nope, that's it. And that's just e to the cotangent of x. Now, what's wrong? We forgot something. What did we forget? We forgot something very important. What's the derivative of cotangent?
Cosecant squared x.
Okay, but it's a co. What do we know about the co's?
It's a negative.
Yes. Okay, so there's a negative in here. So then if I want cosecant squared x dx, I have to put in a negative du. So therefore, there should be a negative du in here and a negative outside and a negative right there. So now it is correct. Okay, one more, and let's see, I won't say it's a challenging one, because some people may not be challenged by this. I'm like, what in the world? Oh, that was where I didn't delete the notes. Okay, here's number 8, last one. All right, what's u?
1 plus x squared.
Tan inverse of x. And what's du? What's the derivative of tan inverse? This is one of the ones you had to know.
Was it 1 divided by 1 plus x squared?
Yes. Okay, so that's in the problem. Dx over 1 plus x squared is in the problem. Okay. Okay, so what's the integral? This becomes e to the u, and dx over 1 plus x squared becomes du. I'm done. These are not hard. Just gonna keep going. All right. Okay, guys, that's it for today. You have recitation with Samuel or Mr. Appiaje tomorrow. Okay. And an exam on Thursday. Let me see. I did want to say something about the topics of the exam. Whoa. I see people have logged off already, but that's okay. These are the topics for the exam. Section 1.6, integrals involving exponentials and logarithms.